All right, let's just jump right in, shall we? We're about to tackle one of the deepest, most fundamental questions anyone has ever asked. Seriously, this is a question that pushes us right up against the very limits of what we can possibly know.
And I mean, really think about that for a second. We're not just talking about empty space. We're talking about no space, no time, no matter, no laws of physics governing anything. Just a complete void. This is the ultimate mystery. And let's be super clear, science still doesn't have the final answer.
Okay, so how in the world do we even start to unpack something that big? Well, we're going to walk through the major ideas, the big roadblocks that make this question so ridiculously profound. Let's start with the nature of the question itself. You see, most of the big questions in cosmology, they start with how. How did the universe begin? You know, the Big Bang, cosmic inflation, all the mechanics of it. But the question we're asking today, it goes one crucial step further. We're asking why. Why does anything exist at all? Why are there physical laws instead of no laws? And the moment you swap how for why, you've left the comfort zone of physics. You've basically hit a wall where science kind of stops, and you find yourself in this really strange, fascinating territory between physics and philosophy. All right, next up. What's so wild about this is that to even have a proper debate, you'd think we could agree on one simple word. But it turns out, physicists and philosophers can't even agree on what nothing really is. So on one side, you've got the physicists' version of nothing, the quantum vacuum. But this isn't really nothing. It's more like a simmering sea of potential energy with particles popping in and out of existence. Then you have the philosopher's nothing, and that is absolute non-existence, the complete absence of, well, everything. Space, time, matter, laws. This disagreement is the whole ballgame. Are we talking about an empty stage, or is there no stage at all? And this quote from a Reddit user of all places just nails it. It was aimed at the cosmologist Lawrence Krauss. Think about it. A bank account with no money in it, that's a state of emptiness, sure, but it exists within a system, the banking system. But no bank account at all, that means the system itself is gone. One is a special kind of something, while the other, that's true nothing. So, from a physicist perspective, the universe didn't necessarily come from absolute nothing. It could have just bubbled up from this pre-existing quantum state, this minimum level of reality that's always buzzing and unstable. But, of course, that just kicks the can down the road, right? It doesn't solve the ultimate problem. It just makes you ask, okay, so where did the quantum vacuum and its laws come from in the first place? Okay, let's keep going, because this leads us right into another huge conflict. This one is all about the very idea of a beginning. I mean, our intuition, our everyday experience tells us that things that start have to have a cause. And this is laid out in the classic Callum cosmological argument. It's really powerful because it's so logical. Step 1, everything that begins to exist has a cause. Step 2, the universe began to exist. Step 3, therefore, the universe has a cause. Simple, clean, makes perfect sense. Or does it? This is where modern physics comes in and just throws a massive wrench into the whole thing by challenging the one thing we all take for granted, time itself. Okay, don't panic. This looks way more intimidating than it is. This is the Wheeler-DeWitt equation. It's a big deal in a field called quantum gravity, which is basically the attempt to get Einstein's relativity and quantum mechanics to play nice and describe the entire universe at its most fundamental level. So this equation, it's trying to describe the quantum state of everything. Now, here is the absolutely mind-blowing part. Look closely at that equation. The variable for time, t, it's just not there. It's completely missing. What this suggests is that at the most fundamental level of reality, time as we experience it doesn't exist. It's what they call an emergent property. Think of it like this. Wetness isn't a property of a single H2O molecule, right? It only emerges when you have a whole bunch of them together. Time might be like that. And if the universe is fundamentally timeless, well, then the whole concept of a beginning or a first cause just completely evaporates. So if a beginning is a tricky concept, that leads us to another wild idea that completely reframes the question. What if the reason for our universe's existence isn't found inside our universe at all? This is the multiverse hypothesis. It suggests our universe is just one tiny bubble in this huge cosmic foam of countless other universes, and each one could have totally different laws of physics. Now, if you have an infinite number of universes, an infinite number of chances, then a universe like ours isn't just possible, it's pretty much inevitable. This is a version of the anthropic principle. We find ourselves in a universe that can support us because, well, if it couldn't, we wouldn't be here to wonder about it. Our existence isn't special, it's just a statistical certainty, somewhere out there.
So, wow, with no single final answer on the table, where does that leave us? Basically, we're left with a menu of profound and honestly pretty conflicting possibilities. So let's just quickly recap the main theories we've touched on. So what is it? Is it that the physicists' version of nothing, that quantum vacuum, was just inherently unstable and was always going to spit out a universe? Or maybe existence is just the default setting, and it's actually nothingness that would be the weird thing that needs explaining? Or maybe, just maybe, the universe is a completely self-contained system, like a causal loop that, in some bizarre way, created itself without needing any outside help. That last idea was really championed by Stephen Hawking. He basically said, as long as the laws of physics exist, the universe can and will create itself. He saw it as a closed system that needs nothing external to pop into existence. But, you see the pattern here, right? That just pushes the question back again. Okay, but why those laws? Why are there any laws at all? And so, here we are. Is our existence a cosmic accident? A logical necessity? Or are we just one of an infinite number of different outcomes? In the end, this question, why is there something rather than nothing? It might be the most powerful question we can possibly ask. And maybe its true value isn't about finding some neat, final answer. Maybe it's about what the question itself reveals, about our own relentless curiosity and our tiny place within this vast, beautiful, mysterious something we call the universe.